Okay, these are the chapter 9.5 notes. We're solving trigonometric equations. This is page 1. So we're going to take everything we did last week, 9.1, 2, and 3, and we are going to use that to solve equations. So let's start with some basics. We are going to solve a linear equation just using sine and cosine. And at first, we're going to compare with the unit circle. So we're going to use the unit circle to solve this. Okay? So as you probably have surmised, trigonometric equations are just equations that involve some sort of trig function. Got to keep in mind that trig functions are periodic. So once around the circle, we may get a solution or 2 or 3 or 4, but we have got multiple coterminal angles, and so it is possible to have infinitely many solutions to an equation. You want to make sure you're paying attention to how your answer is supposed to be represented, and we'll take a look at both of those on this first page. So example 1 here, find all possible solutions for the equation cosine theta equals 1/2, okay? So keep in mind on that unit circle, cosine is positive in 2 separate quadrants. And so we've got this little note down here. Our cosine is going to be positive in 2 quadrants. And that is to the right of the y-axis. So we're looking at quadrant 1 and quadrant 4 values. Okay, so cosine is 1/2 when theta is, let's blow this up a little. Let's change this color. So cosine is 1/2 right here. And so that's where theta is pi over 3. Cosine is 1/2 right here. That's where our theta is 5 pi over 3. So up here, we can look at the unit circle and see that cosine theta equals 1/2 when theta is either pi over 3 or 5 pi over 3. So we have 2 solutions on that unit circle. Okay, so let's compare now with the graph. So on our graph in the middle of the page, that red graph is the graph of cosine theta. The blue graph is the graph of 1/2. Notice that these intersect in more than 2 places, and that's because the cosine function is periodic. Okay, and so let's take a look at how these are looking. Here is my pi over 3. Okay. If I follow the graph through one period, here's my pi over 3. Here's my pi over 3 plus 2 pi. That's one more time around the circle. So pi over 3 plus 6 pi over 3, and that gives us 7 pi over 3. I can also go the other direction. From here, I get pi over 3 minus 2 pi. We got pi over 3 minus 6 pi over 3. That gives us our negative 5 pi over 3. Okay, so when we are asked for all solutions, we've got to consider those coterminal angles that are 2 pi apart, and we're going to make sure that we write it that way. Okay, so let's take a look at the bottom here. A, if we are asked for the solutions just on the interval 0 to 2 pi, notice something. The 0 is included, the 2 pi is not. This interval is half open. 0 and 2 pi are the same, so if our solution is actually 0, repeating it as 2 pi is basically just stating that same solution twice. We don't want to do that. So you will typically see these as closed at 0 but open at 2 pi. Okay, so here, I mean, and we don't even have to worry about that. Pi over 3 and 5 pi over 3, neither of those are 2 pi, and so we're fine. If we're asked for all possible solutions, theta equals pi over 3. Holy moly. Pi over 3 plus 2k pi, or 2 pi times k. Also 5 pi over 3 plus 2k pi. We do need to state that k is an integer. That gives us the opportunity to go both directions, in the positive and negative. And this gives us all solutions that are 2 pi away from either pi over 3 or 5 pi over 3.